All right, so I'll be looking at the corrections to your topic quiz from last week. Let's start with question 1. It asks which of the following is actually a statistical question that you can use for a research project. Remember that a statistical question typically has variance in its answers. Variance in answers. That means there could be more than one answer to those questions. So here, how many days have I been absent from school this year? There's only one answer to that question. So that makes this not a statistical question to be used for a research project. How many students in the school were absent on November 1st of this school year? Again, there's only one answer to that question. There's no variance. We're only going to get a single number that tells us how many were absent that year. How many days have each of the students in my class been absent this month? Well, there's multiple answers here, so it looks like this is a potential answer to our question. This is a potential statistical question. How many students in my class were absent last Wednesday? We're only going to be able to give you a certain number. We're only going to be able to say like 12 students or so. So C is the only correct answer on number 1. All the others only have one answer. And remember, a statistical question has multiple answers to it. So let's keep going on to number 2. So it asks you, you've got all this data about the people going to these ice cream trucks and the ages of them. And so we're trying to figure out which histogram is represented here. So we have the same intervals for each one. Each one starts with 0 to 4. So we should look at our data and see how many students, or people, I guess, are 0 to 4 years old. So we have, it looks like, 2 people right here who are 0 to 4. And so it looks like only 2 in that range. So I'm going to cross this out. Now I'm going to look. This, for 0 to 4, doesn't have 2 people. It has 3 people. So this one is not an option. On B, this has 2 people in the 0 to 4 range, so I'm going to keep that one. On C, they have 2 people in the 2 to 4 range. And on D, they have 2 people in the 0 to 4 range. So A is the only one we've eliminated so far. Let's look at the next range, 5 to 9 people. Or 8 people ages 5 to 9. So we know there's 1 person aged 5 to 9, 2 people aged 5 to 9, 3 people aged 5 to 9, and that looks like it's it. So 1, 2, 3 in that range. So we already know A is not an option. Here, this says 3 people, we can see, so this one still works. This one has 3 people, and so does this one. So that didn't help us eliminate any yet. So let's keep going to the next range. The next range is 10 to 14. So here's an age in 10 to 14. There's 1, there's 2, there's 3 in the 10 to 14 range. So our intervals should go as follows so far. 2 in the first range, 3 in the next one, 3 in the next one. Let's see which of these doesn't work. We already know A doesn't work. Here, 0, 2, 4, we need it to be 0, 3, 3. So B is also eliminated. Continuing, 0, 3, 2, 2, 3, 2. This one also doesn't work. This leaves our last one. 0 in the first interval, 3 in the next one, 3 in the next one. We could check and make sure right here. It says there should be 2 in the 15 to 19 range. Let's see if this agrees with that. Make sure D is our most correct answer. In the 15 or 10, yes, 15 to 19 range. There's 1, there's 2. Let's go back down and make sure that's what we have. Yes, it is. So we found out it should be 2, 3, 3, 2, and it looks like that's the only histogram that matches up. So our second answer must be D. Moving on. All right, Mia's shopping for a new bicycle. She checked the prices at several stores, and they're shown in the chart below. All it wants us to do is find out the mean price of all of those. So remember, to find the mean, we need to go ahead and use our calculator here and add up all of our numbers and get a total. 145 plus 160 plus 175 plus 150 plus 145. That gives us a total of 775. And of course, we divide it by the number of stores that there are, which is 5. And it looks like the mean here is 155. So that would mean choice D is our best answer for 3. Moving right along, let's go to the last problem, the biggest problem, and one of the most important ones based on what we learned last week. So here it asks us to find the mean absolute deviation of the data, and keep in mind, it already tells us the mean of the data. So we actually have to find the deviation from the mean, right? How much they differ from the mean. So here I'm going to say my deviation column Some of you just wrote this are into the table you made already, which is fine. I'm going to make sure I have enough room here. And so I want to think, how much does each value, how far away is each value from the mean? That's what I'm thinking about, from the mean. And remember, my mean is 131. They already told us that. So if you added all these up right here and divided by 5, you wasted your time because it already tells you that here. So I can see already 140 to 131. I know that the difference between those two is 9. That's just a fact that I happen to know. Now you could test that by, of course, subtracting. If you did 140 minus 131, you would get 9. So we did 140 minus 131 to get 9. So then here I would do 131 minus 120, and I would get 11 for my deviation. As I continue, I would do 135 minus 131, obviously only a difference of 4. 160 minus 131, I believe that's going to be 29, but I'm going to check just to make sure. 160 minus 131, 29, I am correct, so I can write 29 here. And then finally 100, this one's an easy one. 131 minus 100, that's just going to be equal to 31. So we have all of our deviations here. Now we want to find the mean absolute deviation. So we want to figure out what's the average distance each point is from the mean. So I'm going to add these up. So I have 9, 11, 4, 29, and 31. So I have 5 values. That means eventually when I get this total, I'm going to have to divide it by 5 to get my mean absolute deviation. So I'm going to add these in chunks here. This is 20. These two, if you reposition these a little bit, it's pretty easy to do. If I take 1 from this 31 and transfer it to the 29, I instead think about it as 30 plus 30, which is 60. So it might be an easier way to do that. So now I can add those two together and I end up with 80. But don't forget about this 4 here. So I end up with, if we add these two together, we end up with 84 total. But of course, we're not done yet. We have to do 84 divided by 5. And of course, you can use your calculator here, but you really shouldn't need to. If you think 5 into 80, right, we know 5 goes into like numbers that end in 0 or 5. I would end up at 80, right? And 5 goes into 80 16 times. So this should be 16 with 4 left out of 5. So this is what I should get, I believe. But I'm going to check my math just to be sure. So let's check and see here. 84 divided by 5. 16.8. Sure enough, I'm correct, because check this out. If I think about this as 16 and an equivalent fraction, I can do tenths to make it into decimals really easy. That's multiplied by 2. That's multiplied by 2. 16 and 8 tenths, that's the same thing as 16.8. So the MAD is 16.8. What does this mean? This means the price of bikes is either about we'll round here, about $17 more or less than the mean of $131. So if you think about what that means bikes are either going to be, like in the middle, they're going to be 131. On the higher end, they're going to be 131 plus about 17. Or on the lower end, they're going to be roughly around 131 minus 17. So it means you have quite the range of bicycles you might have here. You might have 131 plus 17. That might be one, so you might have anywhere from 148 on the upper end to, on average, 114 on the lower end. So we kind of have a range of bike prices here. On average, typically, they're either within 114 to 148, but most hover around 131.